Hello, grade 11. Here, Mr. G, and we are going to make a video on Newton's law of gravitation, universal gravitation. This is a question just about this topic, so let's go through the question slow and see if it's not too problematic. Okay, so this question says Halley's comet of approximate 1 times 10 to the 15 kilograms was 1,3 times 10 to the 8 kilometers from the Earth at its point of closest approach during its last sighted in 1986. Name the force through which the Earth and the comet interact. Now, this, remember, is a force of attraction between all the objects in the universe, and that is going to be the gravitational force. Gravitational force. That is the name of the force that acts between objects that has mass. Okay? Question 1.2. How does the magnitude of the force experienced by the comet on the Earth compare to the magnitude of the force exerted by the Earth on the comet? And this has to do with Newton's law. So you have to write only down greater than, the same, or less than, and then you have to explain. So we have 1.2, we have the comet and we have the Earth. Okay, this is more or less a graphical representation of what is happening. The comet is moving in one direction. Let's say it is moving in that direction. Okay, so we don't care about in what direction is actually the comet moving. It is just moving, and it is a certain distance from the Earth. So there are forces of attraction between the comet and the Earth. They're very far, the forces are weak, but there are forces. So this comet is going to be pulling the Earth towards its center with a force of gravity that we call the force from the comet on, let's see, because that looks like just a word, comet on Earth. And the Earth is pulling the comet toward its center with a force that we are going to call the force from the Earth on the comet. These forces are equal in magnitude and opposite in direction. This is Newton's third law. The Earth is going to be pulling the comet toward itself, and the comet will be pulling the Earth towards itself. That forces are equal. Let's see what is the option they ask here. The same. So we're going to write whatever they ask there. They say the same. The same. Why is the same? Well, to explain this one, you have to say that according to Newton's third law, so I'm going to write here just Newton's third law. Third law states that force of object 1 must be equal to force 2 but in opposite direction. So they have the same magnitude but opposite direction. Alright, so that is Newton's third law. I hope it is clear. Question 1.3. That is quite easy, it's not a big problem. Now question 1.3. They say, will this force increase, decrease, or remain the same as it moves closer to the Earth? So now that force, that force is going to be moving toward. Now we are going to another formula, which is the formula for the gravitational law. Okay, that force, I'm going to write Fg, is equal to the constant of gravitation multiplied by the first mass, in this case is going to be the comet, multiplied by the second mass, which is going to be the Earth, divided by the square of the distance. So from this formula and from the law and from the relationship, you see that this force is going to be inversely proportional. Let's fix that one. It's going to be inversely proportional to the square of the distance between the center of the object. So obvious, if the distance is becoming smaller, the force will be greater. Okay, so the question said, will the force increase, decrease, or remain the same as it moves closer to the Earth? So it will increase. So the correct answer is increase. Increase. Why does the force increase? Because the force is inversely proportional to the square of the distance between the force, the Earth, and the comet. So that is the explanation for this specific question. It is quite simple. And then the last question, 1.4, if the mass of the Earth is 5,98 times 10 to the 24 kilograms, calculate the magnitude of the force exerted by the Earth on the comet. So 1.4, let's write first data. What do we have? Now we have here, it's given to us the mass of the Earth, 5,98 times 10 to the 24 kilograms. We have in the question the mass of the comet. It is 1 times 10 to the 15. And we have the distance between the Earth and the comet, which is 1,3 times 10 to the 8 kilometers. 1,3 times 10 to the 8 kilometers. Now remember, you cannot work in kilometers. You have to work in meters. How to convert? You multiply by 1,000. So I'm going to say times 10 to the 8, and I'm going to multiply it times 1,000. Okay, so the answer is going to be 1,3 times 10 to the 11 meters. So this is the distance we are going to use. And the other data is a capital G, which is a constant, and it will be given to you. The answer is 6,67 times 10 to the minus 11 Newton meters square per kilogram square. Okay, so that is the data. So what formula are we going to use? We're going to use the formula for the law. Gravitational force is equal to capital G multiplied by the mass of the Earth, mass of the comet, divided by the distance between them square. So if you substitute, you have 6,67 times 10 to the minus 11 multiplied by 5,98 times 10 to the 24, everything multiplied by 1 times 1 times 10 to the 15, and everything must be to the divided by the distance, which is 1,3 times 10 to the 11 square. So this is the substitution. We can now get the final answer, which is going to be equal to, the answer is 2,36 times 10 to the 7 Newton. That is the magnitude of the force of attraction between Halley and the Earth. So this is one question. It's not so difficult. It is going to help you with the upcoming exams. So thank you very much for watching. Go through the question step by step. Good luck. Thanks a lot.